My name is Michael Fluitt. I am a technical support engineer for Fusion Reactor. So I've worked with many customers over the years on various issues, some simple, some not so simple. And based on this, I've developed a list of 5 things just to be aware of when you first get an application. So who is this webinar for? In essence, it's for anyone deploying new applications, updating any applications, or even just first adding monitoring to their applications. For this webinar, we'll be running Lucee alongside Fusion Reactor, but the content we're covering almost applies to any application and any monitoring tool. As we go through, I'll be showing Fusion Reactor, but I'll also be mentioning other tools as well that you could use potentially instead of or as well as Fusion Reactor. We're going to cover 5 points today. So we're going to cover benchmarking metrics, error detection, resource usage, background tasks, and alerting on potential issues. So the first thing I think everyone should establish is benchmark performance. So in essence, you want to know how your application performs under real load. So you can do synthetic testing, staging environments, and benchmarking, but that can almost only prepare you for so much. So when you do deploy an application, users can do things you don't expect. You can have higher traffic than you initially thought, which can cause the increased data. And you can even just have user data that doesn't fit the almost traditional shape that you were doing with testing. What I would recommend to benchmark, I usually start with things like throughput, response times, database activity, CPU usage, memory usage, and error counts. The metrics you need ultimately do depend on your environment and how you choose to deploy. I will define these 6 points, but it may be that going forward you want to add or you want to remove some metrics that aren't necessarily helpful to you, just to tune what metrics you do need. I've got my Lucee application running and connected to the cloud. And what I want to do is just show you roughly how I would start by getting off of these metrics. I will first just look at the live view, and that's going to give me an indication of what's running in the last 60 seconds. So I can see my CPU is relatively low. My memory isn't too high, but it's still possibly too high for me. I've got, let's say, 2 web requests and 2 JDBC requests a second, some with errors, and I'm looking at a request time. And then I'm looking at a request time of 500 to 750 milliseconds. So from this screen here, I'm just going to effectively benchmark my applications. What I will also want to do is look at this as on a long-term view. So rather than just looking at the last 60 seconds, I want to look at, say, the last hour, for example. And that's going to give me an indication of really what load I'm going to get over time. You can even go in cloud from last 3 hours to last week. So you can really expand the time depending on what you want to look at. So I can see here that my JDBC request time is relatively low, but around 4:35, I did have a large request spike. And I can see that my request activity resides usually about 0.6 requests a second with a few peaks. My memory is still a slight concern though. So in Fusion Reactor, you can view these metrics on an application or server level, but I've only got the one server. So for me, a server level is more effective. If I did balance out, I may need to change what I'm looking for. So the reason these metrics are so vital is that they give you almost a point in comparison. So what you would want to know is, maybe you look at your metrics now and they're fine. Some of them you'll say that's perfectly acceptable, but you want to make sure that's not creeping over time. The other side of that is, if we look at a metric now and it's not something you're happy with, you can almost use that to set a target of where you want to improve. So there may be things like my memory, for example. I might want to just tune a bit, bring that down because I'm not sure it's going to be 100% stable going forward. So when you have your baseline metrics, what I then like to focus on is error detection. So error detection is something that isn't always something people pay attention to, but I think it's really important, especially because when you do start pushing to new environments, it's easy for errors to creep into your code or creep into your application. So you might not be able to catch them locally or in staging because the data types are different or anything like that. So knowing when you do deploy that there are errors just gives you that early insight into getting a more stable product, but also reducing, in some respects, your support load. If you know you're having issues, you can almost predict and fix that before it occurs. So in my application, I can actually see I do have some errors flowing. I don't have like an error-free application. And I can also just drill into those errors. So if I look at my errors, I can see that a lot of them are loading on my post page. So I've just made a basic forum for this app, but I can see some on my post page, I am getting database exceptions. So with Fusion Reactor, I can drill into that error. So if I look at my error, so this is telling me I've got an invalid query syntax, which is odd because some pages it works and some it doesn't. So what I've already done is I've already actually drilled into this error. And it turns out it's because if I look at my request, this request here is going to post CFM with a post parameter of 1, and it's trying to get the first post. But that doesn't actually exist, which is causing a ricochet database error. Now, this is something you couldn't necessarily predict in staging. It may be that when you were testing in staging, you were testing with posts you knew exist. You didn't test about posts that maybe don't exist. Someone had a bad URL or something like that. So having this context is something that you can always be aware of, just to make sure that when you do deploy, you're not running into roadblocks you didn't know. Fusion Reactor does also have automatic error capture. So on certain errors, what you can do is actually capture the request scope and full context of the error with all your variables. So that would make some errors a lot easier to detect because you know the variables, you can see the code, you can see the query strings, and from that you can almost reproduce the issue without having to in the first place. So there are also as well other tools that can do this. So NerdVision is an example. You could also use Bugsnag, Sentry, and a lot of frameworks even have this built in. So I know, for example, Laravel in PHP has this built in that you can deploy. Same with, I believe, Coldbox. So the last point I want to touch on is just about customer success here. So from a customer support perspective, which is where I mainly reside, what you will find is that when a customer reports an error, it's usually in frustration. Having the power to know that the error is being looked into when they report it is a really good way just to efficiently calm the customer. You can effectively say, yep, thanks for reporting, we're aware, or even better, you can actually proactively warn the customer of an issue. So you can put a message out saying, yes, this is a problem, we're working on it, and that almost resolves the frustration altogether. So my third point is about resource usage. And this is important, I think, especially in more modern applications. When you have your own physical hardware, it can be easy to fall into a trap of if you're running low on resources for whatever reason, you can actually just add more resource. So you might be able to add more CPU, add more memory, and just expand these machines. The trouble is, in the long run, that's not always sustainable. Obviously, machines have a limit to where they can't expand, and also, especially with Java languages, Java isn't so efficient when you give it so much memory. So with Java, I think 8 gig is about the recommended heap size, maybe slightly larger, but you don't want to go too large because then you can make your app almost more unstable. When we also consider things like microservices or Docker containers or even hosted platforms, so AWS, Google, things like this. So when you are running in these hosted environments, you can actually see that you will pay for things like memory and CPU usage, even disk and network. So at that point, it's important that you don't always max out your VMs because it can cost you quite a lot of money in the long run. So in terms of what to monitor, I'm going to focus more on the Java and CFML side here. I primarily am going to focus on things like CPU and memory, so the heap memory and the spaces, as well as garbage collection. So in my case, for my server, if I go to my graphs page, there is a default profile in cloud called Java memory, and you can also create your own that has more metrics if you need. And what you can do here is you can look at your memory spaces and your memory usage. So I can see overall that my heap isn't too bad, but some of my memory spaces are filling up quicker than others. Some this is fine, some it's not so good. I can also see, for example, my garbage collection. I'm getting rid of quite a lot of memory and having frequent garbage collections. So that is something personally I wouldn't be quite comfortable with, and it's just something to always be aware of. Now, other metrics you may want to be aware of. So the CPU and the memory I've just touched on, but especially in hosted environments, disk and network can also be important. If you are paying for your disk and your external network, If you have large requests, large posts of data, that can add up quite quickly. We've seen this ourselves in our services. So it's similar to the benchmarks, our first point. The metrics you need ultimately will depend on how you're running your applications and what's important to you. So over time, you adjust these metrics and these monitoring tactics to kind of suit your environment better. It's all about refinement. So you refine your resource usage and you can manage what's an acceptable level and take that going forward. The fourth point I want to talk about is background tasks. So background tasks and large or long asynchronous tasks can often be a silent killer of applications. So they're not always something you can see. They're quite hard to monitor, they can be quite well hidden, but they can actually have quite bad side effects. Especially when you go to Java and multi-threaded languages, you can have these threads in the background that are actually consuming quite a vast amount of resource, and you won't always be aware of these. What I'm going to do is I'm going to manually trigger a background process just to show you sort of what you're looking for, but for demo purposes, I just want to make sure I can trigger it on demand. So what I've just done is I've just triggered a background process on my server. So what I can see if I then look at my threads is I'll see all of a sudden I have one executor thread for my request. So this one is exec 8, and it's locked in a run state. And this request is going to run for quite a while. So this request is a background task that's going to run for a few minutes. If you have a lot of background tasks that are running for this duration of time, you can really see where the CPU time for this thread, for the lifetime of the server, you can see it's going up quite quickly as these requests run. And it's just something you really need to be aware of so that you don't have so many processes consuming your CPU that the rest of your engine is almost starved. With Fusion Reactor, you can also go a step further. So what you can do is actually just profile threads. So threads that are doing these background processes, I can profile them, and that's going to give me a map of the functions these threads are calling. So you can see the background processes of your thread and what it's doing. So it looks like my process just finished, but this would give you a map of all the methods your thread is running, and you can then look at the code it's running and figure out if it can be optimized, and if so, how. So in Fusion Reactor, you can do this relatively quickly. But again, it's not the only tool to do this. So one that springs to mind in particular is JVisualVM. That will give you a very similar data and a very similar view. I know you can do this in other APM tools and possibly other tools as well, specifically designed for the kind of back-end monitoring of an application and its tasks. So just what I would monitor when I'm looking at this is I'm going to look at the resource usage per thread. So how much CPU is it using and how much actual native processing does that thread need? You can also have threads that are stuck, so they may be blocked or just running a process for a really long time. And you could also have it where you have a request that does an asynchronous call. And that asynchronous call can effectively be locking that request, so that request can't continue. And that could happen for some time, and it's almost very difficult to spot because of the asynchronous nature. So the backend, so I'm just answering a question here from Steve. Where do I view those backend thread tasks? So in cloud, there is, under threads, there is a thread visualizer. If you're on the on-prem version, that would be under resources and thread visualizer. What that's going to give you is the threads and their running state. So I can see as I run requests, I go from the orange waiting state to a green running state. And if you have a long running process, you're going to have almost a solid line of green there. If it was blocked, you'd have a solid line of yellow, for example. So you can use the thread visualizer to try and determine what threads are using the resource. You can also use the CPU sampler. So what that's going to tell me is what threads are using the most CPU. In my case, it's a low traffic server, so there's not, and it's a relatively lightweight app. But if you had a background thread that was using a lot of CPU, you would see that here as the top thread. Okay. And the final thing I want to point out is about alerting on potential issues. So this is something where you kind of combine the first 4 steps and then you add an extra step. So knowing what to monitor in your application is important, but it's also important to know about this automatically. You could have someone manually check these pages constantly, but that's just not an efficient use of time. What you really want to do, if you can, is have these metrics that you know are crucial to alert you automatically if there is an issue. When you do this as well, the other good thing is it will force you to consider what you may consider as an acceptable boundary for your application. So you can look at it and say, okay, if my CPU is this, that's fine, but any higher, I'm going to get slightly concerned. Or if your request runtime goes above a second, that's not acceptable, something like that. So you have to kind of assess what would be classed as an acceptable thing versus what maybe is too high and uncomfortable for you. So Fusion Reactor has an alerting tool built in for this. So what you can do in Fusion Reactor under alerting is you can create alerts as you need them. So what I did earlier, kind of just to demonstrate, is I created 2 checks for my Lucee application. One is just an error count and one is memory, and you can do this for all the metrics you need. So what I can do is set up an instance check for my Lucee instance, and I can do this on, for example, runtime. So I can look at my average completed time for a request, and I can say my average request was under a second. So if I ever get to the point where my requests are taking 1000 milliseconds, I would like to know, because something isn't quite right for me. You could also set up a warning, which will give you maybe something you don't need to react to immediately, but just tell you that maybe something is slightly higher than you would like. Now, one thing I would also like to point out is to check where your alerts go. So in my case, I don't check my email too often, maybe 2-3 times a day. So emailing me with an alert isn't very helpful. For me, sending to Slack is going to be where I would actually see it, because I actively monitor that throughout the day. So when you do send alerts, whether you want that to email or Slack or maybe another tool like OverOps, it's important to put it in the right place so that you can action it immediately rather than have to wait until someone detects it. And when you've got your alert, you can simply save these alerts. So for this, it would be, if at any point during a 5-minute period, my average request response time in that minute is over 1 second, let me know. Then I know I can come in, action the alert, and then respond. So again, this is just how I'm using Fusion Reactor. But you can do this with any tool, and I'm sure there are plenty out there, a lot of which I've never heard of. But if it works for you, and you've got an alerting tool that you know will work, then I would recommend that you put these alerts in place based on the metrics you've already collected. So some alerts I often set with customers. These are the sort of scenarios I'm looking at. If there is a potential loss of service, if an application will become unstable, if any of the metrics you've defined earlier are out of an acceptable range, or really any event where you may need to be proactive and not reactive to a situation. The top 5 things I recommend: you would want to know how your application is performing, know what errors are occurring in the application and if they need to be fixed, know how much resource your application actually needs. Do you have too much? Do you have too little? Things like this. Are there any background processes causing issues? And if there are any of the issues above, will you be alerted if that's the case? So if Fusion Reactor or the cloud specifically, or any part of that, is something you want to try, you can just get a 2-week trial by going to the link on the slide. Or if you go to fusion-reactor.com, there's a free trial button on all the pages and you can get the free 2-week trial there.